Hello, welcome to this video on solving quadratic equations using the quadratic formula and the nature of roots. So we've seen that the general form of a quadratic equation is given by this form: ax squared plus bx plus c equals to 0. So a, b, and c are constants or coefficients. So typically quadratic solutions have two solutions, or what we call the roots, two roots. And the nature of the roots depends on this thing called the discriminant, the b squared minus 4ac. All right, so we've seen that there are three basic ways of solving quadratic equations, either by factorizing, which is not always easy or not always possible, using the quadratic formula, or completing the square. So today we are going to focus on this second method of using the quadratic formula, where you can apply it on any quadratic equation. So the first step in using the quadratic formula to solve quadratic equations is to put the equation in standard form. That is, in this form of ax squared plus bx plus c equals to 0. So if it's not in standard form, first thing to do is to put it in standard form so that you are able to see what is your a, what is your b, and what is your c. If it's not in standard form, then you'll have those coefficients incorrect. So the quadratic formula is useful when factorizing is not easy. That is, it's not easy to find factors of c that add up to give b. So because compared to factorizing, it's a longer method in terms of time, but if factorizing is a bit challenging, then it's better to use this way. All right, so as expected, that typically have two solutions. The first solution comes from using the plus only in the formula, so that you only use the plus there where we have plus or minus. And then the second solution comes from using the minus in the formula. All right, so let's look at examples on how we can solve quadratic equations using this quadratic formula. So we've got this example which says solve for x in the following equation correct to 2 decimal places. So we can see that in this equation we have 4x squared plus 3x minus 5 equals 0. And we should be able to see that it is in our standard form. So we can see from there that our a equals to 4, our b is equals to 3, and our c equals to minus 5. So please be careful with the signs, especially if the sign is a negative. It goes with the sign. Right, so just take note of that. And then in the formula it says minus b. Our b is 3, positive 3. So when we put it there, make sure you take note of that minus. Right, so it's minus 3 plus minus b squared. This is 3 squared minus 4. A is 4 and c is that. All over 2a, like that. So when you put that in your calculator, you can put everything at once. Minus 3 plus square root 3 squared plus 4 and I get the first solution as x equals to 0.80 to 2 decimal places, or when I put the negative now, I get the solution as x equals minus 1.55 to 2 decimal places. All right, so that's how we just easily solve that using the quadratic formula in our calculator. Let's look at a second example now. So here we're solving for x in the following equation. All right, so 2x bracket 3x plus 5 minus 11. So you can see that this is not in standard form. So the first thing you want to do is to expand and combine like terms and then write in standard form. So when you expand it, you'll see that you have 6x squared plus 10x minus 11 equals to 0, right? Which is what we have there. Then now it's in standard form. You can see your a is 6, your b is plus 10, and your c is minus 11. You put that into your equation and into your calculator to try and solve for x from there. So for the first solution with the plus, I get x equals to 0.75 or 76 to 2 decimal places, right? Or x is equal to minus 2.42. Right, so those are the two solutions that we get for that example. Looking at a third example now. So for x in the following equation, correct to 2 decimal places as well. So 3x minus 1 over x equals 5. So you must see that now this is not in standard form as well. So we must first try to get it in standard form. And how do you do that? You want to first get rid of this x in the denominator. And how do you do that? By multiply by x throughout. So that when you do that, you get 3x squared minus 1 equals to 5x. Then you rearrange it now in standard form and you get this equation here. So in our standard form, that's our equation, 3x squared minus 5x minus 1 equals to 0. Then you see now, okay, that a is 3, b is minus 5, and c is minus 1. And using that, you plug into the formula to solve for x. Okay, so I get the first solution as x equals to 5.54, or the second solution with the minus comes x equals to minus 0.54. So we have been fortunate that in the examples we've looked at, we've been getting solutions. But there's a point where it's not possible to get real solutions. That is, real solutions. All right. And that can easily be determined by looking at this thing that we call the discriminant. So that's where we come to talk about the nature of roots. So what are we talking about here? So we're saying the nature of the roots of a quadratic equation, those two roots of ours, is determined by this discriminant. And there are three cases. The first case is you have no real roots. So when the b squared minus 4ac is less than 0, because this is the term that goes under the square root. So remember, you can't have a real number that is the square root of a negative number. That's why we say when that thing is less than 0, you have no real roots. And when the discriminant is equal to 0, you have two equal real roots, or what we call repeated roots, right? Repeated real roots. And if the discriminant, the b squared minus 4ac, is greater than 0, you have two unequal real roots. All right. So in most of the examples we looked at just now, we were seeing that we had this case of two unequal real roots. So sometimes it might be necessary to try and figure out what values of some variable can help us to get either real roots or no real roots, and so forth. So let's have a look at typically how questions are asked under this. So in this example, we're given a function of x equals to x squared minus 5x plus 2. Part A says solve for x if function of x equals to 0. And part B says for which values of c will function of x equals to c have no real roots. So just remember what we said. So if you want no real roots, it means we want to look at this case. You want our b squared minus 4ac less than 0. Just remember, you first have to have your equation in standard form. Fortunately, in this case, equation is in standard form. So to solve it, just set it equal to 0 and plug into the quadratic formula, and this is what we have, right? Because you can see our a is 1, our b is minus 5, and our c is positive 2. So plugging into the formula, I get these two solutions. X equals to 4.56 or x is 0.44. Now, to answer part B, for which values of c will function of x equals to c have no real root. So we first set our function of x equals to c, but this is not the standard form of a quadratic equation. Standard form must always say equals to 0. So we rewrite it and we form this standard form. So looking at our standard form, we see that that's fine. Our a is 1 and our b is minus 5. What is our c now? It's not just 2, but this whole thing together with the c. So it's 2 minus c becomes our c in the standard form of the equation. So the b squared minus 4ac then becomes this, right? And we're saying for no real roots, it must be less than 0. All right. So just expanding that and solving for c, that inequality, you'll solve it and see that c must be less than 17 over 4 for our equation of the function of x equals to c to have no real roots. So that's typically how they ask those questions. So you can get another question that says, for what values should you have real roots? So remember, when it just says real roots, it includes the equal and the unequal case. So for real roots, your b squared minus 4ac must be greater than or equal to 0. And then for two unequal real roots, that's when it's only greater than 0. All right, so thank you for watching this video. I hope you have learned how we deal with solving quadratic equations and paying attention to the nature of roots.